So welcome back, and today, as promised, I'll look at the refraction through a prism. A prism that we have taken, a simple prism, which is a triangular prism A, B, C. This is a section of the prism, and the ray of light has been shown to emerge coming from P to Q, and inside the lens it goes through Q to R, and it emerges on the other face AC, which makes an angle E, angle of emergence. These green lines are the normals drawn to the two faces which meet at the point N and the rays, when extended straight, they meet at the point M, and therefore you can see that the total deviation is equal to delta. This angle we take as the angle of the prism A, okay, and the incident ray over here makes an angle of I, and then there is an angle of refraction R1, and here I call this angle over here as equal to R2, and this angle is equal to angle E. Okay. So these are things which are described the two faces AB and AC of the prism. Okay. Now delta is the angle between this and this, has been defined as the angle of deviation. Now we take the quadrilateral, okay, QNR. Okay, the angles of the vertices Q and R in this quadrilateral, they are all 90 degrees or right angles, shown over here. So, and the total angle is in a quadrilateral 360 degrees. Therefore, because this and this is equal to 180 degrees, so this and this will also be equal to 180 degrees. Okay, which I call equation number 1. From this triangle QNR, R1 plus R2 plus the angle QNR over here, this is equal to 180 degrees, because the total internal angles of a triangle is equal to 180 degrees. Okay. So now when I compare this equation with this equation, okay, 180, 180, this, etc., then we find that R1 plus R2 is equal to the angle of the prism A, equation number 3. Now deviation at the face AB, the deviation at the face AB, here we have shown this as this one, okay. This delta 1 I can write here as delta 1, okay. This deviation is taken as I minus R1, and that at the other face the deviation is taken as delta 2, and this is E minus R2. So the total deviation is equal to this plus this, and that turns out to be equal to I plus E minus R1 plus R2, which is taken as equal to A. Okay. So the total deviation is the sum of the incident angle and the emergent angle minus the angle of the prism. Now we can see that from this equation it is evident that this delta is a function of I. It depends upon the angle of incidence. Okay. Now if I plot a graph between I and delta, then we find that this red curve has been shown over here. I have not taken the enumeration of the angles, etc., which you can find from textbooks. They write it 40 degrees, 50 degrees, 60, 40, 50, 60, etc., etc. But in one situation that we have, the angle of incidence is this much, and the angle of deviation, emergence turns out to be this one, which I mark as E dash. There is one situation in which the angle of incidence and the angle of emergence become equal. Okay. At this point you can see that the deviation angle is a minimum. Now, which we call delta min or dm. Now see that here it is that I and E are equal. Okay. So it means that if I trace back, then the ray of light will become such that the angle of incidence becomes equal to angle of emergence. This angle becomes equal to R1 and this R2 and this then delta, etc., etc. So you can see that. The one thing which appears to me and to you also, that in case this deviation is there, then the angle I becomes equal to angle E, and in that case R1 becomes equal to R2. Because if it is coming like this, then this becomes R1, this becomes R2. So under the situation of minimum deviation, we find that the R1 is equal to R2. Okay, and I is equal to E. They can be exchanged, and delta becomes equal to what I say dm. So with these things we discuss it a bit further to obtain the formula for deviation, etc. Okay, so we could write that because E is equal to I, and the rays can retrace, therefore R1 is equal to R2 is equal to say R. Angle of refraction is R. So that the angle of the prism becomes equal to A is equal to R1 plus R2 is equal to 2R. R is equal to A by 2. Similarly, as we found that delta is equal to angle I plus angle E minus angle A. So therefore I can write I plus I minus A, or dm is equal to 2I minus A under the condition of minimum deviation. Or I could write that I is equal to dm plus A upon 2. Okay, from this origin. Thus, using Snell's laws, applying the Snell's laws, mu21, which is equal to mu2 upon mu1, okay, is equal to sin I upon sin R, is equal to sin of dm plus A upon 2, sin of A by 2. So this equation that we have, this actually gives the value of mu2 upon mu1 or mu21. For a small a, that is, if we have a very thin prism, so there will be a small value of dm, and mu12 can become equal to, if the sine of dm plus A upon 2, so it is dm plus A upon 2 divided by A upon 2, okay, sine of theta is approximately equal to theta. So that relation I get dm plus A upon A, which is dm upon A plus 1. So I can write that dm upon A is equal to mu21 minus 1, which gives the value of dm as equal to A mu21 minus 1. Okay. So thin prisms do not deviate light much, and this is the case of a monochromatic light of any color. But if we have, instead of a monochromatic light which is coming onto the prism, if there is say white light, which is a combination of so many colors, then what we will get is that there will be a dispersion, okay, which I'll just draw for you. tell you how the dispersion takes place and how white light can be converted into VIBGYOR. Okay, that is violeting, indigo, blue, green, yellow, orange, and red colors. So that is it. Even if it is say the two distinct wavelengths of a yellow light, then there will be a dispersion in the two colors, and that can be obtained. Okay, and this dispersion earlier people thought in the bygone days, during the days of Sir Isaac Newton, that the prism is responsible for the colors of the rays, but which Newton could show that by putting an inverted identical prism over here, that of course when the light is coming from the first prism and the light is coming from the second prism, there is again a white light that I am going to show to you just now. So we just carry on and discuss with you the dispersion of white light, which is a composite light composed of many colors and which splits in a spectrum, a dispersion spectrum of white light, which I have been able to show slightly to you because this is the red light variations, and then yellow, and then etc. Finally it is the violet color in the end. This is a glass prism, and what we get is the dispersive spectrum of white light. So we get VIBGYOR, okay, the famous VIBGYOR that we know about. Now, initially, once upon a time, people thought that the dispersion is due to the prism. Okay, white light is coming and then the prism is able to give the colors. But later on, there is an experiment where two prisms P1 and P2 were used, identical prisms with the same angle of the prism A here and A here, and I have not been able to show this very properly, but this is the white light and the emerging light is also the white light. You can see for the proper diagram in your books. So these two inverted prisms, so here it splits into red and violet, and this red and violet together give a beam of white light. Okay, so this is one phenomenon associated with the dispersion of light. We find that the color basically depends upon the wavelength and several wavelengths are there, and the velocity of the dispersive medium is also a function of the wavelength lambda. For example, here the red light travels faster than the blue light through the glass medium, dispersive medium. Well, there we come sort of to an end of this refraction through a prism. Then we got to discuss some natural phenomena like the rainbow, the scattering of light during the day. Then we had to talk about the optical instruments, in which the important instrument is the eye, microscopes and telescopes, etc. But this I postpone to take up later on, and the next topic that I am going to talk to you about is the wave optics instead of ray optics. Okay, so meet you soon, and after some time we talk about these phenomena which you may read by yourself, and I can discuss it later on. Thank you very much. See you again.